Hey, seventh graders, we are on our last section of this unit, and we are going to talk about direct variation. And we're going to talk about direct variation because it's a special type of linear function. Okay, so this is the first rule. It needs to look like y equals kx, or k equals yx if we would have gotten the k alone, okay? Rule number 2, it has to have a constant k. So those are kind of the two big rules here. So the reason is because a direct variation means that something's directly related to each other. So for example, the amount of, beans, or amount of money I pay is going to affect how much I can buy, that type of thing. How much money I have affects how much I can buy. Sorry, sometimes I'm bad at thinking of examples on the spot. So we're just going to look at a couple equations, then we're going to look at a couple tables, then we're going to look at a couple graphs in order to tell if things are a direct variation or not. So it means it has a direct relationship. So the first rule is, can you get y alone? And when you do, does it look like this? So for example, if I wanted to get y by itself, I would divide both sides by 2. Okay. Now this one's kind of tricky sometimes because in our brains it looks like this. Now, does this look like that? Well, not necessarily, but what really happens here is that there is a 1 in front of this x. So this turns into 1/2 x. Now does it look like this? Yes. And what is the k? Well, the k is 1/2. Okay, let's do another one. This one, if I want to get the y alone, I'm going to move the 1 to the other side. Y equals 2x minus 1. Now, does this one look like this? Well, kind of, but it has this, that -1. So that means that something else has an effect on this xy relationship. So this means that no, it's not a direct variation. And the reason it's not is because of that. Okay, let's go on to C. If I wanted to get y alone, move that 8 to the other side. I get y equals x minus 8. Again, does it look like this? No, because it has this. So no, not a direct variation. Okay. Last one, if I want to get y by itself, I would divide both sides by that 3. And I get y equals 2/3 x. So is this a direct variation? It is. Because it has just that 2/3 there, nothing is added on. And then we're going to say that our k equals 2/3. Okay. So when we are going to identify a direct variation from the table, this is different than just deciding if something is linear or not. And the reason it is because if it's a direct variation, the relationship between the x and the y should be the same every single time. So our k should equal y divided by x. So what's 3 divided by 1? 3. What's 6 divided by 2? 3. What is 9 divided by 3? 3. So because there was a constant here, that means that yes, this is a direct variation. It's a direct variation, and I'm going to explain this in our notes because our y divided by x equals 3, and it equaled 3 for all of them. So let's try the next one. What if I take 3 and I divide it by 10. Well, I get 0.3. What if I take 1.5 and I divide it by 20? I'll just show you. Just do this on your calculator. 1.5 divided by 20, and I get 0.075. And the last one, if I take 1 and I divide it by 30, it's going to get even smaller. I get 0.03. So even though sometimes we like, oh, 10, 20, 30, 3, half, or 1.5 and 1, it kind of looks like there might be some sort of pattern. These are not the same. So it does not have a constant. There is not a constant. And I'm going to say between X and Y. So it's not a direct variation. Okay. Now graphically, it's probably one of the easiest things to figure out. So the big thing on a graph is that it has to go through the origin. Okay, it can look differently, can look all sorts of different things, but it has to go through the origin. Okay, so this is the rule. Has to go through the origin and be a straight line. Okay, so this one is a yes. And then if I drew one like this, even though it's straight, it looks very similar. No. Or even if I went something like this. No. And it couldn't go like this. These are all no's. I think you get the idea. So it has to be straight and has to go through the origin. So if you have a graph, that's probably one of the easiest ways to figure it out. Okay, the last type is the little word problems. It says an eastern box turtle travels on the ground at a speed of 18 feet per minute. Give an equation to represent the situation and determine if it's a direct variation situation. So the big thing here is, what are our factors? Okay, how long the turtle gets to travel, and how far does he make it? Okay, so if you guys were writing a little equation, I would probably write something like this. Y equals 18x. X being the number of minutes that he is traveling, and then y being the total distance. So if you can express it like this, is it a direct variation? Yes. What's our constant? Our constant is his speed. Okay, so that's a really good example of just where there's two factors. How long he gets to travel, how far he got. It's a direct relationship, a direct variation. Okay, so a little bit shorter notes, trying to keep it under that 10-minute mark. Your worksheet, you've got the equations. Most of them are already y by itself. If it is direct variation, identify the constant. 7 through 12, you have to tell me if it's a direct variation. If so, tell me the constant and write an equation. So if so, make sure you do this part. And then the last part, we've got a couple graphs there, and then just a few word problems on the back. This last sheet of graph paper was just for in case we needed it. When I sent these home, I just really wasn't sure if they would come in handy. And so if you used them, that's great. So that is all I have for you today. We will plan a review next week and have a quiz.
So I hope you guys are doing great. I miss you like crazy, and we will talk to you later.